If you are given to draw the structure of certain elements like hydrogen, which has the proton number 1 and the mass number also 1, if we are asked to draw the structure of an atom, which we call as orbital diagram of the element, so we'll draw it like this. First we have to draw such a size of the nucleus in which we can write the symbol of the element, which is H, and then we have to write the number of protons present in the element. So here you can see that there is one proton present in the nucleus of this atom, so you will write H and then one proton present. You also have to write down the neutrons present in the nucleus in this, but here you see that 1 minus 1 0 neutrons present, so you will not mention any neutron present in this nucleus of this atom. So you only have to mention H and then one proton, and then you have to draw a nucleus surrounding this, and then you know that then you have to look at the number of electrons. There is one proton, so one proton, and so there will be one electron. Number of proton is equal to number of electron. So what you will only you only have one electron to draw, and for that you will have to draw a shell around this nucleus, and then you will draw an electron. You know that the first shell can't contain more than 2 electrons, so here the number of electron is even less than 2, so you just have to draw one shell, and so we'll only have to draw one shell and draw one electron in it, not more, and your orbital diagram for the element hydrogen is complete. Now coming to helium, which has the symbol He, and then the proton number 2 protons, and then the mass number 4, then 4 minus 2 is equal to 2 neutrons. So here you have to mention 2 neutrons and then draw a nucleus surrounding this information, and then you know that 2 protons, so 2 proton is equal to 2 electron, so you have to draw 2 electrons. For that you have to first draw a shell around the nucleus, and then you have to draw 2 electrons. So you know that the first shell can contain 2 electrons, not more than that, and here you have to only draw 2 electrons, so it just fits in the first shell, and here the first shell is the valence shell of this atom. So over here your orbital diagram for the helium element is complete. And now coming to fluorine, which has the symbol F, and the proton number 9, so 9 protons, and then the mass number 19, so 19 minus 9, 10, so 10 neutrons, and 9 protons, so 9 proton is equal to 9 electrons. So for that you have to first draw of one shell around the nucleus, and then draw 2 electrons, not more than that. And now you see that 9 minus 2, 7 electrons are still left, so you can't draw them in the first shell, so you have to draw another shell for that, and then draw the rest of the 7 electrons in that shell. You know that in second or moving on, you can't draw more than 8, but here there are 7 to be drawn, and so they can easily be adjusted in the second shell. So here your orbital diagram for fluorine is complete. Coming on to neon, its symbol is Ne, 10 protons, 20 mass number, 20 minus 10, 10 neutrons, 10 protons, 10 neutrons. 10 protons means 10 electrons, so for that you have to draw 10 electrons. First you will draw one shell, and then you have to draw 2 electrons if more than that, and here there are more than that, so 10 minus 2, 8 electrons to be drawn still, and then you will draw another shell, and then draw the rest of the 8 electrons in the second shell. If you were to draw more than 8 electrons, then you must have to draw another shell for that, because in the second or moving onwards, you can't draw more than 8 electrons in those shells. So here your orbital diagram for neon is also complete. For chlorine, Cl 17 protons, and 35.5 is your mass number. So 35.5 minus 17 is equal to 18.5 neutrons. So you have to list down it like this, 18, and then you have to draw a nucleus, and then 17 protons, so 17 electrons, you have to draw 17 electrons. First shell 2 electrons, not more than that. Then the rest 8 electrons in the second shell, not more than that. So 8 plus 2 10, already done. Now how many are you left with? 7. Now 7, 1 2 3 4 5 6 7. So you can adjust 7 in the third shell, even 8, but not more than 8. So here your orbital diagram for chlorine is also complete. And now coming to potassium, K is its symbol. So K, 19 proton number, 19 protons, 39 mass number. So 39 minus 19 is equal to 20 neutrons present in the atom. So 20 neutrons, and then the nucleus, and then the first shell 2 electrons, not more than 2 that, and then the second shell 8 electrons, 8 plus 2 10. Now you are still left with 10 more electrons, so another shell 8 electrons, and now you are still left with 1 electron. So in the last shell 1 electron. However, the last shell can adjust it, but here you are only left with 1 electron, so you will only draw 1 electron, and so its electronic configuration like 2 8 2 8 8 1. What is this actually? It is actually that in the first shell you have, this is your electron, in the first shell you fitted 2 electrons, so 2 in the first, and then in the second you fitted 8 electrons, and then in the third you again fitted 8 electrons, and in the fourth you fitted 1. So this you have to write, this is your electronic configuration, 288 1. Over here, if you consider the electronic configuration, here it comes out to be, in first you fitted 2 electrons, in second you fitted 8, and then in the last you fitted 7. So 287 here, 2 8, and then in the previous ones here 1 only, here 2 only, and here 2, and then 1 2 3 4 5 6 7. So this is your electronic configuration. As you can see that how many how many you have to write down that how many electrons you fitted in each shell sequence wise. For example, here in the first shell and in the last one, first and the last 2, first 2, second 7, second and the last 7, here first 2, second and the last 8, here first 2, second 8, third and the last 7, first 2, second 8, third 8, fourth and the last one, valence shell 1. So you have to write them down as your electronic configuration.